Welcome to the last session of Unit 1, and in this session we'll be looking at application of calculus in physical chemistry. This is a very short session, and by the end of the session you'll be able to apply derivatives in solving physical chemistry questions, apply integration in solving physical chemistry questions. To begin, we'll take some few examples which will help us understand what the session is all about. As a first example, find the half-life of first order reaction if the reaction constant K is given as 2.0 times 10 to the power minus 3 per second. To do this, you should be able to collect the first or the half-life of a first order reaction, which is the natural log of 2 divided by K. Approximately, that is 0.693. So to do this, we substitute the 2.0 times 10 to the power minus 3 per second into the equation, which is given as natural log of 2 divided by K. Substituting the value of K will result into 350 seconds. Now, if our constant was given to us in minutes, then the answer would have been 350 minutes. So find the time when only 1% of the reactant remains. It is necessary that you recollect the equations of a first order reaction, second order reaction, and zero order reaction. However, I understand if you are not following up to this point, please, you're not alone. Just hold on. In our next unit and then sessions, we'll be dealing with rate of reactions. We'll be looking at the rate constant of a reaction, the rate expression of a reaction, and then we'll also be looking at the rate constant and how to find their various units. We'll also look at the equations of a first order reaction, second order reaction, zero order reaction, as well as their half-lives. So to calculate the time when only 1% of the reactant remains, it is necessary you recall that Kt is equal to natural log of the concentration of A, that's the initial concentration of A, plus the natural log of the final concentration of A. Knowing this formula, then we can substitute our values inside to find our time, and that gives us 2300 seconds. To continue, we want to find the second order reactions activation energy with the given information. So we are given an initial K value, K1 and K2 at 37 degrees and 87 degrees Celsius. Now, for you to be able to solve this question, it is also necessary that you recall the activation energy equation, which links one temperature to another. So the E here represents the activation energy, and this represents the gas constant. Then these are the various temperatures. Note that you have to convert the temperature in degrees Celsius to Kelvin. To do that, we simply add 278 to the value given to us in degrees Celsius, and doing that, the answer becomes 1.1 times 10 to the power minus 1.1 times 10 to the power 4 joule per mole. Basically, this is it about calculus for chemistry students. We've talked about differentiation, we've talked about integration, we've looked at definite and indefinite integration, and I hope that in our next sessions where we'll be delving much into the main chemistry, I will see you, and I hope that we'll interact with each other, and I hope that if you have any questions, we can find the appropriate channel and then I can help you address them. Thank you.